Evelyn, thank you so very much for asking me. I am evangelical about this particular meeting. I have told my colleagues across the United States and actually across the world, because I'm also a consultant in the first private sleep centers in all of China, that if you want to learn something about narcolepsy, you go to this meeting. You will learn more about the disease and the people with narcolepsy than you will ever learn in a textbook, in a lecture, or anywhere else, because you will never find a concentrated group of people who know more about the disease than any doctor I know. So my hat is off to you folks, because you have taught me so much. You heard a lot about narcolepsy from the master. Dr. Mignot is world famous. And a lot of what I'm going to be telling you is going to be kind of reinforce what Dr. Mignot just taught you. But I do it in a little different kind of way. These are my disclosures. I have done the pivotal trials for Jazz. We're currently involved in the Avidel-Flamel once nightly sodium oxybate trial. I've worked with Vanda on circadian rhythms. I've worked with Merck on the Orexin antagonist for insomnia. And I've worked with Synovian. So I have a lot of experience. I've been doing this now for close to 37 years. So I've seen a few things. You saw the history slide that Dr. Mignot put up, but what I want to do is I want to break it down in timelines, because we have learned more about narcolepsy and the control of wake and sleep states in the brain in the past 20 years than we have learned over the past 200 years. And that's important, because what you just heard from Dr. Mignot, that the NIH is stopping funding, this incredible roller tsunami of research is going to be coming to an abrupt end. And that's catastrophic. It's not only catastrophic for you with narcolepsy, it's catastrophic for science and humankind in general. And when our present administration came in, the first thing that was said was that they want to cut the NIH budget by 30%. Well, you just might as well put a bomb in the middle of the lobby and blow it up, because you can't do research and then suddenly, out of the blue, cut 30% of its funding. I'm sorry. I think funding medical research is a lot more important than building nuclear bombs. But that's my own personal feeling. So here you see a timeline of the discoveries that started in 1877, going through about 1935. This was the golden age. 1877, 1880 was when the disease process was first described, and the very first papers were published. Lowenfeld was the first to characterize cataplexy in 1902. And then different people called it different things, and we eventually got to the point where we are all accepting of the same definitions. Now, as Dr. Mignot pointed out, what Konstantin von Economo did in the 1920s, culminating in a talk he gave at Columbia University in 1929, was to establish that sleep actually is controlled by distinct parts of the brain. Prior to 1929, nobody knew what part of the brain sleep and wake were controlled by. So this was an incredible hypothesis that was only really confirmed in 1998, when orexin hypocretin was discovered. But here you see the first treatments of the disease. 1935, the use of amphetamines to control daytime sleepiness. And ephedrine, which was the very first stimulant, was described in 1931. This is the second big push, 1955 to 1983. And this is my lifetime. I graduated medical school in 1974. So this is how I grew up in terms of my knowledge base. Kleitman and Asherinsky described the discovery of REM sleep, 1955. Dement and Kleitman were able to point out the different stages of sleep and different things happening to the body in different stages of sleep in 1957. 1957, Yost and Daly from Mayo Clinic were the first to describe the narcolepsy tetrad, and that is excessive daytime sleepiness, cataplexy, hypnagogic hallucinations, and sleep paralysis. 1960 was the first time cataplexy was treated pharmacologically, and that was with imipramine, a tricyclic antidepressant. And then in 1963, sleep onset REM periods were discovered as the pathognomonic change when we were looking to diagnose narcolepsy. We had no way to diagnose it other than by clinical description. But now we were able to have a biological marker based on sleep studies, and that was 1963. So we're getting to the modern age, but you can get an idea how 100 years worth of study, and then now starting in the 1950s, suddenly things are accelerating. MSLT testing, Richardson and Carskadden codified the MSLT in 1978. In fact, it was 1978 when the American sleep groups first got together, and the very first meeting of sleep researchers and clinicians was in 1978. Then, in 1983, Honda in Japan was the first to show that there was a gene that was associated with susceptibility to come down with narcolepsy, and that was the discovery of the HLA-DR2 DQ10602 gene. 1983. This is all recent history. And this is 1998 to 2014. So again, we're compressing timescales. And you're seeing how research is exploding. And I would hate to see a big X in 2017, meaning no more research. But you heard from Dr. Mignot that the hypocretin orexin molecules were discovered in 1998. And they were discovered within 2 weeks of one another. One group in California, one group in Dallas, Texas. And the papers were published within 2 weeks of one another. And then it was a little bit later that the discoveries were found to be of the same compound. That the group that described orexin and the group that described hypocretin were really, in fact, talking about the same peptides. They just named it different things. And here you see that we were able to develop animal models. 1999, a group in California and Boston were able to create mice that were bred to have no orexin receptors and no orexin manufacturing. Then in 2000 was the seminal paper on the lack of orexin in the brains of patients with narcolepsy. So this now established without any doubt what the pathophysiology of narcolepsy is. What is the cause of narcolepsy with cataplexy? And that is either the absence or the very significant clinical reduction in orexin in the spinal fluid in brains. In 2002, sodium oxybate, Xyrem, was approved to treat cataplexy. And in 2005, a supplemental new drug application, supplemental NDA, was approved to treat both excessive daytime sleepiness and cataplexy with sodium oxybate. The drug Provigil was approved in 1998 to treat excessive daytime sleepiness, and the subsequent medication, which is what we call a isomer of modafinil, was approved in 2007, and that, of course, is armodafinil, or Nuvigil. Now, what an isomer is, all chemical compounds in their natural state have both a left and a right-handed configuration, because organic compounds are three-dimensional. And if you have what we call a racemic mixture, it's a combination of both the right and left-handed molecules. What they found was that the right-sided compound had a little bit more efficacy. It lasted a little bit longer in terms of biological half-life, and as such, they were able to get it approved as a separate drug as armodafinil or Nuvigil. So that's the difference. It's the same base, but it's only the right-sided version. The left-handed version has been removed. Then, as you saw, basically based on large epidemiological studies in China, Dr. Mignot and Dr. Han showed that there was a statistically very significant association between the H1N1 influenza pandemic as well as the effects of H1N1 vaccination with the causation of narcolepsy type 1. JZP-110, actually, the very first papers were written in 2013, 2014, and a compound which you just got introduced to, pitolisant, which is a drug that is being used to improve wakefulness and possibly cataplexy, has been approved in Europe. It has not been approved in the United States because there are no trials in the United States for approval for pitolisant. The drug in Europe has a brand name that's called Wakex. We are also very much involved in looking at the once-nightly sodium oxybate trial with Flamel and Abadel, and these are ongoing trials. You know that the pediatric trial for Xyrem is in its final stages. So we have lots of things that are coming up, but as you also saw, these are kind of partial treatments. The holy grail, as you heard, is the replacement of the Orexin that is missing in the brains of type 1 narcolepsy. So now let's talk a little about the disease itself, something that I think most of you know about. And when Evelyn asked me to talk about Narcolepsy 101, it was really just to give you a 30,000-foot overview of what the clinical manifestations of the disease are. And here you see a list of the classic pentad of signs and symptoms. Yost and Daly described 4 components. We now know that there is a 5th. And the 4 seminal components, the original excessive daytime sleepiness, cataplexy, hypnagogic hallucinations, and sleep paralysis, and to that list we have now added disturbed nighttime sleep or fragmented nocturnal sleep. Narcolepsy is, of course, a lifelong neurologic sleep disorder, and if you want a very kind of broad overview, it is characterized by the disruption of the boundaries between sleep and wake states, and in the sleep states between REM and non-REM sleep. So in a normal individual, there are discrete times that you are awake, discrete times when you are asleep, and discrete times you're in REM, and discrete times where you're in non-REM sleep. In a narcoleptic, there's blurring of all of those boundaries. And when you have REM intrusion into wakefulness, you can get sleepiness, you can get cataplexy, you can get hypnagogic hallucinations, and you can get sleep paralysis. Now, the disturbed nighttime sleep is such that narcoleptics do not sleep longer than normal patients. So if you typically sleep 8 hours a day, normally a narcoleptic will sleep 8 hours a day, but instead of having that sleep concentrated in the nocturnal time frame, it's now spread out over the entire 24 hours. So it's got to come from somewhere, and that is to create this disrupted or fragmented sleep at night. So that's the explanation for disturbed nighttime sleep. Now, in addition to the seminal 5 attributes, there are other symptoms that have been described as part of the symptom complex. Automatic behavior, possibly related to the onset of microsleeps, where an individual can be driving a car and not remember how they get from point A to point B. Sitting there writing notes, and after they regain consciousness, they're seeing handwriting, but it's gibberish, gobbledygook. They don't know what they wrote. That's automatic behavior, but they're still able to hold the pen or pencil and write something on paper. Loss of concentration and memory, we now know that, and we now call it narcofog. And I think everybody in this room knows what that is. You can get visual symptoms. You can get blurring of vision because the muscles of accommodation of the eye are voluntary muscles the same way that you have voluntary muscles in your arms and legs. So during a cataplectic episode, you can have blurred vision that goes in and out, and that can be the only manifestation of cataplexy, is episodic blurred vision brought on by emotional stimuli. You heard the description of type 1 and type 2 narcolepsy, and we're going to talk about that a little bit more. Now, the other interesting thing is that narcolepsy typically doesn't occur in isolation. It is very commonly associated with other sleep disorders. It's been estimated that 25% of narcoleptics have obstructive sleep apnea, 20 to 25% have restless leg syndrome, periodic limb movements in sleep, REM sleep behavior disorder, where you start to act out your dreams, and nocturnal eating disorder have all been described at increased numbers in patients with narcolepsy. But I think, as all of you know, the very first symptom is excessive daytime sleepiness. But the problem with narcolepsy, it is the great imitator. And for doctors who don't know anything about narcolepsy, which is the vast majority of doctors out there, including doctors who think that there are board-certified sleep doctors who are trained in pulmonary sleep medicine, but don't know a damn thing about what's between their ears. That daytime sleepiness is commonly mistaken for things like daydreaming, insomnia, drug abuse, depression or bipolar disorder, apathy, attention deficit disorder, and sometimes cataplexy is very frequently called seizures. I have seen patients who have had hypnagogic hallucinations been diagnosed as having schizophrenia. So it depends what doctor you see. Psychiatrists will call it depression or attention deficit. Neurologists frequently will call it epilepsy or seizures. And they don't put the whole condition together. Cataplexy, to me, is one of the most interesting phenomena because we really don't understand it because it's very variable. No two patients of mine with cataplexy have the same kind of muscle weakness, nor do they have the same trigger. The usual trigger are positive emotional stimuli, laughter, mirth, happiness, tickling. One of the most common triggers of cataplexy is orgasm. So these are positive emotions, and they trigger cataplexy. But again, no two patients are alike. You can have cataplexy, as I just described, with just visual blurring or obfuscation, all the way to complete paralysis, falling to the ground. And for some individuals, it can vary. It can be narcolepsy cataplexy in the arms one time, another time it could be falling to the ground. So we don't really understand why there is this degree of variability. Most cataplexy involves muscles from the waist up. Only 30% involve muscles of the lower extremities. But typically, again, in younger patients, it is more facial, head and neck musculature that gets weak, slurring of speech, elongation of the face, and drooping of the eyes are the most common in younger patients when they develop cataplexy. So here you see the last bullet point usually develops within 3 years of the onset of daytime sleepiness. I had one patient who had it 41 years after the onset of sleepiness. And he was HLA positive. We did not get a CSF Orexin level on him, but he was HLA positive. But he clearly was able to know that 41 years after he started to develop cataplexy. Sleep paralysis, the inability to move for a few seconds or minutes during sleep onset and offset, is normal. If you had a normal population and you ask who's here ever developed a feeling that they were paralyzed, particularly when you're transitioning from sleep to wakefulness, 90% of the people will raise their hand. There's a feeling of falling, of free falling, and then what happens is the individual panics. There's a sympathetic or an adrenergic stimulation, which breaks the paralysis and the person can move again. But in narcolepsy, you can get sleep paralysis at any time. And it can come on very similar to cataplexy, but it's typically at transitional periods of sleep, when you're falling asleep or when you're waking up. And it's not just nighttime sleep, it's paralysis during the day into daytime naps. Again, the last bullet point, paralysis ends spontaneously. Fear reaction is the most common, or a mild sensory or tactile stimulation is enough to break the paralysis. I've had patients who have had their animals, typically a cat, will walk across them and break the paralysis. Hypnagogic hallucinations, as I said, can be mistaken for schizophrenic hallucinosis. These are vivid waking dreams that occur again during transitional periods. Hypnagogic is occurring at sleep onset. Hypnopompic is occurring at sleep offset, occurring upon awakening. They may accompany sleep paralysis or occur independently. They can be tactile or auditory. There are people who have hypnagogic hallucinations where they only have a sensory phenomenon. They feel like something's crawling on them, a snake is on them, an insect is on them. There's no visual or cognitive hallucinosis, it's somatosensory. And I've had several patients who have had that. There is some awareness that of their surroundings is preserved, again, because it's happening in that transitional phase from wakefulness to sleep. It needs to be differentiated from dreaming while asleep. This is occurring transitionally, whereas dreaming starts when you're asleep. And here's the disrupted nighttime sleep, frequent arousals, wakefulness after sleep onset, frequent shifts to lighter planes of sleep, and there is no prolongation of a return to sleep. In other words, that these are not like insomnia patients who wake up at night and then 2 or 3 hours later go by and they finally fall back asleep. Patients with narcolepsy, it takes between 10 and 15 minutes and they're back asleep. Several studies using polysomnography have shown that there is decreased non-REM sleep and slow wave activity are the possible mediators of fragmented sleep. And when you get decreased slow wave sleep, you don't have the glue that knits sleep together. And one of the pharmacologic properties of sodium oxybate is to increase slow wave sleep, which is one of the reasons why this medicine works well in order to knit sleep back together. Age of onset of narcoleptic symptoms is a double peak. There's a median age of 22, but then there is also a second peak in the 30s. So we don't know why there is that second peak, but we seem to think that that first peak around puberty is one of the issues that allows the HLA system to mature, and if there is the proper trigger, an infection, be it flu, strep throat, that would activate the HLA system to attack the orexin cells in the hypothalamus. This is a slide that you saw earlier. This is the Chinese epidemiologic study. And what I want to point out here is that here you see in the red how there are peaks and valleys over the years. And what Dr. Mignot showed you here, this is the breakout from this, where most of the peak diagnosis occurs in the spring and summer, and then as the fall goes in, it drops off, and then it starts all over again, probably because this is the time when there is, in the infectious process, in winter when everybody is in very close quarters, and in China, believe me, there are very close quarters with lots of people. So over the years, you see this increasing. I mean, there is no question that the timeline is increasing, but of course, this was the onset of the pandemic of the H1N1 swine flu. And you see this huge spike. And that's where we really put the pedal to the metal to try and figure out that this was, in fact, a very good case for cause and effect. So, worldwide, there is a very significant underdiagnosis of the disease. It's been estimated that only 50,000 of the estimated 200,000 Americans with narcolepsy have been correctly diagnosed. It's almost as common as multiple sclerosis and Parkinson's disease, but you don't see any narcolepsy 150 bike rides. That would be quite a thing to see anyway. But I wish there were. I wish there was more recognition of the true extent of this illness. The average individual has gone between 7 and 10 years from onset of symptoms and has seen between 5 and 7 physicians. And within those 5 to 7 physicians, the average is 2 sleep doctors, 2 board-certified sleep doctors. We ain't doing a good job. You heard about the narcolepsy and immunity. I'm not going to go through that because you had a whole lecture on it. Now, just a few words about orexins. It is the loss of the orexin cells that typifies type 1 narcolepsy. Type 2 narcolepsy, not the case. And that's why I agree with Dr. Mignot that type 2 narcolepsy is far more closely aligned with idiopathic hypersomnia than it is with type 1 if you have normal CSF orexin. But as he said, there are a group of patients that are in the never-never land zone where there is a reduction but not complete elimination of CSF orexin. So these are patients we don't know quite how to define at this point in time. As you saw, Dobermans are afflicted with it based on an autosomal recessive gene. Humans, it is not a genetic disease. And you saw this slide earlier. This is the hypothalamus of a patient with narcolepsy. This is a normal hypothalamus. And here you see with peptide staining how there is a very, very severe reduction in the orexin polypeptide neurons versus a normal peptide staining. So there is no question that this is type 1 and why people have type 1 narcolepsy. You heard some comments about how we measure sleepiness. We can do it with subjective scales. Stanford Sleepiness Scale measures how sleepy are you at the moment. The Karolinska Sleeping Scale also measures how sleepy you are at the moment that you're taking this test. The Epworth Sleepiness Scale is designed to see how sleepy you are over a period of time. But the vast majority of people who answer the ESS do it how sleepy they are when they answer the questions. They don't really read the instructions. So it's not a great test, but it's been validated and every sleep lab uses it. And that's why we still need objective testing, PSG MSLT testing. MWT testing is really used in research. But Dr. Mignot's point is very, very well taken in that the MSLT can be negative, but you can still have narcolepsy. I've done up to 3 MSLTs before I was able to demonstrate the REM intrusions into wakefulness. So 1 negative MSLT in the face of an overwhelming evidence of narcolepsy should not be discouraging. You just need to find a sleep doctor who believes the same way and will push the insurance companies to let you get the test until you can get the diagnosis. Sleep medicine is using technologies that's 50 years old. I have more technology in my watch than we have to do sleep tests based on mainframe computers and everything else. So Dr. Mignot's statement about finding a way to do a test for narcolepsy without having you sleep a night and a day is taken by me to heart, because I think that's very critical. We need to get into the 21st century. We are only sitting in 1957 when we were discovering REM sleep by using surface electrodes. So we have a long way to go. Hypocretin testing, in the United States, it's almost impossible to do. There are 4 labs, 5 labs actually, mainly affiliated with universities, that got permission to do the test. The FDA has not cleared an orexin, clinical orexin test on spinal fluid. China, I can get a CSF orexin level on any patient in China, in any hospital, even in rural China, I can get a CSF orexin. I can't treat the disease, because treating the disease, as Dr. Mignot very well put it, in China is very difficult. But I can make the diagnosis far easier there than I can here. You talk about a dichotomy, that's dichotomous. When a doctor orders a PSG MSLT, there are things that you as patients should know that many times the doctor doesn't. And that is, the PSG should be done only if you've had 6 hours of recorded sleep during the test. If you've had 4 hours on the PSG, the MSLT should not be done. You need to show that you've had at least 7 to 8 hours of sleep per night over the week before the test is done. Typically, you want to give somebody a sleep diary or an actigraph or the Fitbit watch, because all sleep deprivation in the week prior to that test or too much sleep can skew the results of the test. So it's very important to do the test under the proper circumstances. You should be off REM suppressant medications. Antidepressants, SSRIs, tricyclic antidepressants, MAO inhibitors. atypical antipsychotics, all need to be withdrawn and tapered off and washed out at least 7 to 10 days before you do the test. Because if you're on a REM suppressant right up until the time you do the MSLT and you don't have any REM sleep, well, then you don't know whether it's because you don't have narcolepsy, it's because you're on medicine that is suppressing the REM sleep from showing up. I don't know how many times I've seen PSG MSLT tests on patients who never stopped their antidepressant medications right up until the night they take the test. And that invalidates the results, if it's negative. Now, if it's positive, that's another story. But if it's negative, it does not mean that the individual does not have narcolepsy. And again, for the same reason, you have to stop stimulant medications at least a week before the test is done. Sodium oxybate lasts for a very long time. 4 weeks actually may be too short, but that's what I do. When I retest somebody who's been on sodium oxybate, I give them a 4-week washout. You heard about the classification based on the American Psychiatric Association in 2013 and the American Academy of Sleep Medicine in 2014. According to the shrinks, if you have cataplexy, you don't have to do anything else. But Aetna, Cigna, Blue Cross Blue Shield, and United don't accept a paragraph that says this patient has cataplexy, and they will deny treatment. So you have to go ahead and do the formal testing anyway. So that's the American Psychiatric Association. The American Academy of Sleep Medicine, as you heard earlier, breaks it down into narcolepsy type 1, which is narcolepsy with cataplexy, and presumably CSF hypocretin levels or orexin levels of less than or equal to 110 picograms per milliliter. And here is type 2, where you don't have clinical cataplexy, but you are sleepy. Your MSLT shows a mean sleep onset latency of 8 minutes or less, and at least 2 sleep onset REM periods. And you can include the overnight sleep test. If you go right into REM sleep on the overnight study, that will count as 1 SOREM. So there is REM intrusion on type 2. If you do a spinal tap and orexin levels are above 110 picograms, then, and you have the positive sleep testing, then you are classified as a type 2 narcoleptic. Idiopathic hypersomnia has excessive sleepiness, 8 minutes or less on the average sleep onset latency of the MSLT, but no evidence of sleep onset REMs or less than 2 SOREMs on the testing. Management, you're going to hear a lot more about management today. In fact, we're going to be talking about treatments in the medications panel in the next hour. Prior to Xyrem, people were treated with stimulants, and in the United States that can include methylphenidate, which is Ritalin, amphetamine salts, which is Adderall. Modafinil, as I showed you, was approved in 1998. The only drug that is FDA approved to treat cataplexy is sodium oxybate. There is no other drug that has FDA approval. But historically, as I showed you, starting in the 1960s, tricyclic antidepressants were shown to be effective, and more recently, selective serotonin reuptake inhibitors, SSRIs, have been shown also to be effective. The ones that we are using today actually are the SSNRIs, which both affect serotonin and norepinephrine. The SSRIs are serotonin. SNRIs are a combination of serotonin and norepinephrine. And here you see, to treat both EDS and cataplexy, standard of care, according to the American Academy of Sleep Medicine, is sodium oxybate. Goals of treatment, well, telling you what the goals of treatment are is like carrying coals to Newcastle or selling ice to an Eskimo. You know what the goals of treatment are. We want to reduce daytime sleepiness. We want to reduce or eliminate cataplexy. We want to control the ancillary symptoms, the nightmares, the hallucinations, the sleep paralysis, and we want to give you better nighttime sleep. We want to improve your cognitive functions, reduce the narco fog as much as possible, and get you folks back to work or back to school. And ultimately, we want to improve the safety of you as a patient and the public at large. There have been some very interesting studies in 2013 and 2014. Data was analyzed of close to 1,700 respondents about what the patients with narcolepsy expect from their treatment. And the problem was that if you looked at it, only 42% of people who were on treatment showed improved cognition, whereas 52% showed improved fatigue. So that leaves a huge number of people who are not being adequately treated. Despite treatment, patients continue to struggle with daily symptoms of residual daytime sleepiness, 65%. Constant fatigue, 37%. Cognitive impairment, 41%. And these are on treatment where the doctor who was treating them thought that it was optimal. If that's optimal, I hate to think what suboptimal is. We know that there are non-pharmacologic treatments that work, behavioral treatments. Taking of strategic naps is important, and all of you know that here. Maintain good sleep hygiene. One of the worst things a narcoleptic can do is to work different shifts. You need a very regularized sleep onset, sleep offset. Your circadian rhythm is still present, but it needs to be reinforced by conscious attention to sleep onset and sleep offset. Patients with cataplexy typically avoid emotional situations likely to induce cataplexy, and there is the absolute need for psychosocial support. Family, school, job, and education are vital. Here you see some of the adverse experiences with modafinil. Headache is the #1 adverse event, and I have seen it, and I've had to stop the drug in around 20% of my patients who we initially prescribe it for, and our modafinil is the same way. These are some of the anti-cataplectic properties. I'm not going to go through each one, but the ones that we use now typically are venlafaxine, or the brand name is Effexor. And here you see sodium oxybate, sodium salt of gamma hydroxybutyrate. What happens is that when the drug is acidified, the salt is cleaved off and GHB is left, and that gets into the, crosses the blood-brain barrier into the brain. Half-life is 30 to 60 minutes. You have to allow at least 2 hours after eating. I typically tell my patients 3 hours, and the nocturnal dose is typically split, half the dose at bedtime, half the dose 3 to 4 hours later. Some of the more significant adverse events, people have had onset of major depressive disorder, and I've had to stop the drug in 2 patients of mine who developed suicidal ideation. There is a high sodium load, and right now Jazz Pharmaceuticals is testing a low sodium or a mixed salt solution for sodium oxybate, and the drug has the potential for respiratory depression. Treatment initially can cause significant weight loss. And I think, okay, and here are some of the other adverse events. And just to finish up, non-hypocretin-based therapies. As you heard, sodium oxybate pediatric trials are finishing up. Pitolisant is now available in Europe. That's the histamine augmenting drug. JZP-110 you heard about. The once nightly micropump sodium oxybate, Avadel and Flamel is doing that, and they're here at this meeting. Flumazenil and clarithromycin are being used for idiopathic hypersomnia tests. And there is a brand new one that is being gone through phase 1 trials, and that is melanin concentrating hormone antagonists. Whereas Orexin is a wake promoting system, Orexin cells and MCH cells actually are tightly bound in the hypothalamus. MCH cells are sleep promoting cells, and if you can get those working, you can, and antagonize them, you can perhaps improve wakefulness. So these are some of the newer drugs under therapy. And of course, the holy grail is the replacement of hypocretin. And that's it. So I thank all of you for your attention. Thank you.
It's a local artist.
Oh, thank you.
Very much. It's good to have you here.
Believe me, I'm glad to be here. All right. Hope you enjoy the rest of your time here, everybody.